Great, because, when we look at furcated teeth, the canals come into the pulp chamber at pretty much awkward angles. They don't just come up into the pulp chamber. They come and bend in coronally into the pulp chamber. So when colleagues start to come in to a canal without removing the triangle of dentin, you'll see they handle the file frequently off axis. In fact, when I teach, I even say your assistant knows you're doing it wrong. Because she looks over and she goes, my God, the handle's way over here. How is he going to negotiate the recurvature deep? So you want to get those triangles out, because the canals, when they bend in, what I didn't emphasize, and we'll have graphics at another show, those canals anatomically before humankind has ever entered the tooth are closer to the furcal side concavity than the outer wall. So if we're looking at the mesial root under that molar, and we have a triangle of dentin that I showed at the whiteboard earlier, if we leave that triangle on, those canals are already closer to the furcal side, so as you drop a rock into a pond of water, you'll get concentric emanating circles. Well, that's what a rotary file does. It cuts blindly north wall, south wall, east, west wall. So the preparations drift, and they get closer to furcal danger. And sometimes there's overt strip perforations. Maybe
so people who don't...
During this... these pages of discussion on what we previously taped and they're listening to, there will be many times that we'll jump around to different ideas like triangles of dentin, furcal side concavity, pericervical dentin, the Farrell effect, and we'll be talking about these different things. I could probably get up if the body holds well, and I could probably make it clear over to the board.
If you have something you want to talk about over there, go ahead.
All right.
I actually, while you're going over there, I'll just say this, and we've been talking about for all of the 6 years the importance of removing triangles of dentin. And I've heard you say so many times you want to be able to look into the access cavity and see the orifices without having to really move your head around. And I always kind of thought, honestly, is that just kind of like an OCD thing that you just want your workspace all cleared so you can work easier? But now I asked you about it the other day, and I noticed that when you were saying this, like when you put your file in and the handle's way off axis versus access, way off axis, then I'm getting now that it's curving to go into the canal. And then if you have a curvature later in the canal, it will have to curve again. So then you are having to deal with a double curve versus just going straight down and then dealing with the one curve. And that does seem, you said, yes, it's safer, it's more efficient if you don't have to deal with the double curvature.
One reason I brought this up, we had just shown the group, the three amigos, the three occlusal views, but I wanted to pick out this article, not because I have great admiration for Marco Martignoni.
Which you do.
Which I do. It's like my son. He could be my son. But really just because I wanted to show this paper. This was a really great paper. This paper emphasized you can use caries to influence your access. We've talked about that, you and I have. He also, they talk a lot about missing marginal ridges. So you could have a mesial marginal ridge or you could have a distal marginal ridge. But restorations that have traditionally come through this area and then they maybe come out like this, and everybody knows they're like 3 surfaces, they can be 2 surfaces, but when you lose a marginal ridge, if you lose a second marginal ridge, they found that there was considerably weakness of the tooth post-endodontics regardless of the type of access. Let me say it a different way. They found out that if you had intact marginal ridges, there was no difference between this one and this one. None in strength and flexural strength post-endodontics, endodontically strong teeth. So this paper was very, very good. It was published in the JOE, and it has great drawings, and I just reviewed it again yesterday. But I've been hearing, well, truss accesses or teeth are stronger. There is up and down literature on that, and there are abundance of papers, and this is one of them that shows there's no difference. So that was just not necessarily an accurate remark that I saw in the discussion forum.
Okay.
And then maybe we've been beating this to death. We've been beating this to death. Sometimes, since you're coming in like this, front of the mouth, you don't need to take out that triangle because you can just kind of come in here and drop right in. So fine, that's good. But it's much, much different to come over the marginal ridge. Now you have to stand the file up. But no, you got to stand it all the way over to here so you can start to have a handle over here like this, and you're starting to come in like that. And that is definitely off axis. And what we're trying to do is kick that handle over and get that handle over here on axis. And that means the triangular ridge. So we've been beating around the triangular ridge. I thought maybe we should just see a visual, Lisette, so they can really see it. And then the double bend, when you have canals that bend into the pulp chambers, and they do, and sometimes they bend in less, sometimes a lot more. If you start to draw a tangent line here and a tangent line like that, that's your angle. That's quite a bit of a divergence from the long axis. And then now we have a canal that goes like this, and we have a canal that goes like this, and you could see you're approaching 90 degrees. So when Lisette said, you know, you're kind of complicating it by not removing the triangles of dentin, and she talked about the double curvature. Well, there's a coronal curvature and there's an apical 1/3 curvature, and that's what she's talking about, and that's what we talk about quite a bit.